Okay, so the question that I introduced in the last video was to evaluate 5 to the power of pi, and we want it correct to 2 decimal places. So I've written out the first few decimal places of pi here, and saying that pi is between 3 and 4 is definitely not going to be enough, but we'll start there anyway, just as we did with the last one. So this means that 5 to the 3 and 5 to the 4, so we have 125. Oh, sorry, need to switch my brain on today. 5 to the power of pi is less than 5 to the power of pi, which is less than this times 5, which is what, 625. Okay, clearly far too big an interval. So we know that pi is between 3.1 and 3.2, which means that it's between 5 to the power of 3.1 and 5 to the power of 3.2, which means it's between 146.83 and 172.47. Again, smaller, but not quite enough. So it's between then 3.14 and 3.15, which means that 5 to the power of 3.14 and 5 to the power of 3.15. So it's between 156.59 and 159.13. Again, clearly not enough. So we then know it's between 3 to the 3.141 and 3.142, because it's 3.145 something. So I'll leave out my middle step of raising it to these powers. So 5 to the power of 3.141 is 156.84, and 3.142 is 157.096, or 10. We could have that as. So again, closer. Let's then look at the next one. So 3.1415 and 3.1416. So that means it's between 156.97 and 156.99. We're very, very close now. We only have one decimal point left to go. We can tell that it's going to be 156.9 something. So then we need 3.14159 and 3.14160. And that then gives us that it's between 156.992 and the same answer as we got in the previous one, 156.994, and I've done this now to 3 decimal places just to check that there's no rounding. So I can say that 5 to the power of pi is equal to 156.99 to 2 decimal places, and we're done. Now, I know that you might say, well, as I'm using my calculator for all of these, I can just use my calculator for this too, and that gives me the approximation. But it's not so much about the solution here, it's more about the process. This idea that we had in the first video of approximation is a really central idea within mathematics, and it's something that we're going to need more and more often. So finding an answer that's good enough rather than the perfect answer. And I think this shows this idea of approximation in a reasonably easy to understand way of why we need it and how we can get there. So I hope this was helpful. If you have any questions, then please write them down or ask me in the next lesson. If you'd like to practice 1 or 2 more of these, then exercise 98 on page 24 has a few more different ones for you to try. Otherwise, I hope this has all been clear.